Hi, David. Welcome to Swarm Stack.
Thanks for having me, Sabine.
Well, we've worked together in the past, and it's always been great brainstorming with you about the future of swarm robotics. And there's a paper that really stood out to me, that's based on your ideas. It's your work, and it's about designing robot swarms, a puzzle, a problem, and a mess. And I thought we could jump in by talking about that work and what you were thinking.
Yeah, thanks. Yeah, I think this was one particular paper that was super interesting to write. It came of the realization over the kind of the years I've been working on some robotics about how we, the researchers, think about designing collective behavior at different scales, at different terms, with different resources, from very minimalistic scenarios with simple robots like the epoch or the kilobots, where we see the realization of particular collective behavior, to kind of newer approaches or advances about how to deploy collective behavior at scale to assist in intralogistics or other problems. But the interesting part was that kind of finding that we all talk about the same. We always talk about design, although we are referring to different problems, different scenarios, different starting points for conducting the research. So I think it was quite interesting to try to, let's say, put together everything in a framework to see how these differences between the different scales happen, what you have available, what you don't have available, and maybe try to set some kind of roadmap towards having real robot swarms, starting from the advancements that we have seen in the last 20 years on the field.
So, in your own research, what would you say you've been focusing on to this point? The puzzles or the problems, and the future is the mess? Huh?
Yeah,
Maybe you can give some
so
examples.
exactly. So so we adopt this framework that is coming from organizational theory. I heard about it in a podcast that I totally recommend. Is Simplifying Complexity. It's already finished, but it has really nice topics for us that work with complex systems. And they were talking about how in organizational theory they also see the problem of having multiple agents that have different resources interacting at different levels, right? And sometimes they find problems within kind of organizations that can be easily solved because you understand everything that is happening. So who's responsible for doing one activity and what happened, what went wrong with that activity, so you can actually address that problem. But sometimes you have too many interdependencies of different departments that actually need to kind of feedback to each other, and everything becomes very difficult to assess why your organization is not working in the proper way. So I thought this resembled a lot in the way that we see design in swarm robotics, and in this framework, they specify these three levels of complexity that are puzzles, problems, and the mess. So in a puzzle, in the way that they define it, they see that, let's say, in the design process, all information is available. It is possible to isolate the puzzle in a way that you know what are the intervening factors, and with enough time and expertise, you can find one solution. And once you find the solution becomes repetitable. So this feels a lot for me to the kind of early studies and still ongoing studies on understanding the principles of self-organization. So how do we make a robot swarm aggregate? So how do we make flocking with a robot swarm? So once we have figured out the rules that tell the robots how to achieve this collective behavior, we can move on and we can reproduce it and extend it to other robots, right? So this is the puzzle. So in a way, we discover simple rules that then can be reproduced and repeated for obtaining this collective behavior.
And you've solved lots of puzzles, I would say, throughout your
Yes,
PhD and your postdoc leading up to now.
exactly. So yes, I have been studying in my case, automatic design. So how to generate collective behaviors using automatic methods and some applications of optimization and artificial intelligence. What is interesting is that these can be kind of generalizable and can be used across different types of self-organization in different systems, relying on the same kind of design principles. I feel that in the swarm robotics literature, since the very beginning, we focus on these puzzles, right? So on understanding emergence in a way and self-organization. But as we have been maturing into an engineering discipline, we need to start looking into the more general perspective. And this is where I feel that some recent advancements in the application of AI and automatic design have taken us at this moment. So in the next level of complexity, we have the problems. So a problem is not anymore a single specific instance of a puzzle where we can have all the information, but rather we introduce some uncertainty. And instead of having a single solution to the problem, we might have different solutions that have different trade-offs. And it will be up to us, the designer, to decide whether to put the trade-offs so that we can obtain a specific outcome. So I feel that this is the current state of the art in swarm robotics, where we are addressing problems. So we know that there are multiple instantiations of self-organization and collective behavior we can achieve with certain rules. Now, how do we leverage these rules in different ways to use robot swarms to accomplish different tasks? This is a problem because you can use some form of, for instance, flocking for collectively transport objects, but you might also need to use some form of aggregation to keep the robots together. You might leverage some decision-making processes along the way. So in the automatic design processes, let's say that we're trying to find, let's say, different methods that can combine these rules of organization to achieve a given performance in the task that the robot needs to perform. So this is kind of the things I have been working mostly.
Do you think the problems bring us closer to application? Is that one of the key differences between the puzzles and the problems, in the sense that we need to combine different things because they're applications, they're very rarely fully constrained, and so are these problems more applied?
Indeed, yeah, I think that for us the problems make sense once we start thinking of robot swarms as systems that can help us to solve tasks or solve different missions. Once we are able to put a performance metric to what the robots do, and we have an intention of a specific task that might require the combination of different behaviors at different stages, we start talking about problems. So we still can find, say, a combination of behaviors as typically, for instance, constructed via finite state machines or behavior trees, as people have done in Bristol. And once we find the specific combination of behaviors that allow the robot swarm to perform well in a task, we can bring closer let's say, the application of swarm robotics to these specific scenarios. But this may be that if we want to, for instance, do aggregation in a squared space or the flocking in a square space as we have in Bristol, the robots might need a specific tuning of the behavior, but we think in a kind of larger space, that kind of more open space, we might need to find a different, or slightly different maybe instantiation. So finding these automatic methods to, let's say, finding this
to make it
combination
work.
Of behavior, exactly. So, and to make it work with a certain performance. So I think this is kind of the change.
Yeah.
We switch from finding just the specific rules to aim to performance. So, and this is where we transition to an engineering discipline. So we want things to be reliable, reproducible, and understandable to some extent as well.
So then the mess. Should we embrace the mess? Does that mean our systems need to become even more general? Does AI help in the mix in terms of everything that we're reading about currently?
So yeah, in this organizational framework that we adopted, the mess expresses the fact that there are some problems, but basically these are systems of problems. So we are not considering anymore just flocking with a certain performance, so how to move things from one place to the other at a given rate, a given speed or frequency. We are thinking that we need to move things from one place to the other where we have people in the way. So where we are working in kind of intralogistics scenario where we cannot control all the system. Or if we want to move, let's say we want to clean the city, so with a robot swarm. So this means that the robots will need to understand context and scenario and traffic and so on. So it's not anymore just about the behavior per se, but it's the behavior in a context of other problems that need to be addressed. And the interesting part is that there is very recent literature that tries to address the problem as a design process as well. Despite that, I think this is where we need to make the great breakthrough about how to leverage all these ideas and all this knowledge we have about swarm robotics, their capabilities, their properties, also their weaknesses, but in this more messy context, right, where we have people intervening, other machines intervening. So I feel that for taking robot swarms to the real world, we need to jump into the mess. But this means that probably we need to also develop new tools. So I feel that what we have so far is a good starting point, both understanding the rules of self-organization and how to design methods that generalize that self-organization to specific tasks, but that's not sufficient. So we cannot put all the problems into an objective function and try to optimize for that. So we really need to think the problem in a different way to find other solutions.
And I wonder if there'll be different philosophies for how we approach the mess, because I'm inclined to embrace the mess and react to it and find a way to work with it. And I think there's also a tendency to want to master the mess and make it less messy by having models of it and whatnot. So do you have a sense for what might work well for swarms, or is it early in the day and maybe a bit of both, depending on what tools we have?
I feel that, so if we imagine the robot swarms that will work in real world, in my view, they really need to be open. So open, be able to, sometimes being able to learn, other times not being able to learn, because I think there are scenarios for both cases. But not trying to restrict too much the system, because it's difficult to think all possible interactions that the system can have, let's say, with this environment. So I think we need a different philosophy in this case on how let robots. So what is acceptable in flocking, for example? This is one of the aspects of some robotics. In my case, kind of in my view, robot swarms, for example, are not necessarily meant to be efficient because we get other properties, we get redundancy, and we get other kind of important aspects of having multiple robots interacting with the scenario. And this is one thing that I really like. Is okay, I'm happy that many robots maybe are slacking off while working, but once the load of work increases, they are able to cope with it, right? So I think we need to find this kind of maybe realization, accepting that some parts of the swarm are good enough or are okay or sufficient to operate in these messy environments. And it's a matter of how we see the application of robot swarms in the scenarios, not necessarily focusing on over specific performance metrics, but rather to provide a service or what people is happy with, you know.
That's really exciting and a good pathway forward, I think, for the field. Lots of work to do there. Congrats on your new faculty position. What are you looking at now?
Oh, thank you very much. Yes, I started on November as an assistant professor at University College Dublin. I'm the School of Mechanical and Materials Engineering. The university is particularly strong, and the faculty and the school is particularly strong on manufacturing. So I will be working on using robot swarms to support manufacturing processes. My idea for this is both. It builds a bit on the work I have been doing so far. One of them is leveraging stigmergy. I think stigmergy is a great behavior where robots interact, communicate by modifying the environment, and it's a really nice idea. I think it has not been explored much. We typically develop intelligence for the robot that are based on direct communication, but communication through the environment is something that has not much been explored. And I think it would be great for manufacturing because the robots anyway interact with objects in the environment. So they need to modify objects in the environment. So for me, that is kind of a nice touching point. And the other aspect I want to explore is onto the economics of this. So how to make these robot swarms that are working in a factory really economically viable. Because I feel that we need to find the value for the technology to be adopted. It's not enough, I think, for let's say for companies to say, yeah, we'll need to deploy 1,000 robots and they will not give me, I mean, it will be just 100 working and the other ones will be working around. So we need to find these specific kind of scenarios where the economy of the robot swarm starts working. So I'm interested in those topics.
So maybe touching on both of those, the stigmergy question I think is really interesting because we do use stigmergy a lot. It's not just the ants putting chemicals in the environment to be able to create paths. I was just thinking last night, in my house I have I have multiple floors, and then when I want something to go from one floor to the other, I put them on the stairs with the hope that someone's going to pick them up and bring them one floor up or one floor down. And I can imagine in a manufacturing setting, people do the same thing, right? They bring parts to a location. And so I agree, that's been quite understudied. And you can both observe and react to the changes to the environment, but you can engineer them.
Yeah. So this builds a bit on the ideas we explored together in Emerge, in the European project we worked on when I was in Bristol. The idea of interfaces, right? How do we communicate with the swarm? How do we have these 1,000 robots that still need to interact with people? So, okay, we can give screens to the people, something that we consider at that time that is something we are used to now, but maybe there are more organic ways to interface. So, and I think StigMerge is one of them. As you said, like you can drop a box of material, and if a robot passes by and sees that box shouldn't be there, actually should be somewhere else, it will just pick it up and transport it. So there is no need for direct communication. I don't need to put myself in a Wi-Fi network and start receiving information from the robots. I don't need to communicate to the robot and wait for a robot to come and just give an order to it. So I think StigMerge is a very nice way to interface in these scenarios if we want to keep simple, let's say, the system. So that's why I'm particularly interested, and indeed it's something that I feel it got traction maybe in the early years of swarm robotics, but then it has been kind of taken over by more direct communication systems.
Cool. And then on the economics of it, there's been some ideas around the gig economy bubbling up. I know that this is an idea that you've been exploring, even talking with economists and really trying to understand the cross-disciplinary nature of this question. But there's been others as well on the Swarm Stack. A few weeks ago, we talked about Waymo and how they have a system to be able to task people to check in on their cars. And in the ARIA report recently, this summer, there was also released a section on the robot gig economy. So it is bubbling up, and it brings up all sorts of philosophical questions. So I know it's early days, but what do you find exciting in this space?
So for me, this is quite an interesting point, because in my view, what I would like to happen for robotics is that robotics is owned by people and is not owned by big corporations that provide just robotics as a service. So I imagine, so robot swarms in one way can be deployed by a single entity, right? So it could be myself, that I have my manufacturing company, and then I deploy the robot swarm to work there. But I think robot swarms will emerge as a more organic realization of robotics at a household scale. So if I start having my 2-3 Roombas, and then you, Sabine, have your own 2-3 Roombas, and then we have an activity where we need to clean a large space, we can bring it together and they will start forming a swarm. So I would like to think that there will be personal robotics, people owning different kind of robots that will have different shapes, different sizes, different capabilities, and we will be able to let these robots interact and cooperate in an organic way. So it will be like a bottom-up emergence of robot swarms out of the robotic landscape. And I would like to start thinking that people can, let's say, leverage the robots to generate wealth for themselves. So for me, there is something that is a bit concerning, is thinking in a future where all the wealth we can generate with robotics and the welfare we can generate with robotics just goes to let's say, a very few number of individuals or corporations, and they profit from, let's say, all the exciting things we are doing now. I really would like that somehow this wealth is redistributed to the people, allowing them using the robots also to work for them. And you were mentioning Waymo, that is a nice example. They are starting trials now or they will start trials about using autonomous driving to provide. No, it was not Waymo. I think it was Uber, maybe.
It was Uber, the poster they used to show me.
So it was Uber that will start trials, or they are trying to start trials on London of using autonomous driving to provide part of the Uber service, right? But this is a bit puzzling, because Uber has been one alternative for the economic development for people that traditionally might not have access to the more formal labor market. And if we start thinking that we let a single corporation as Uber just take over the whole service, well, this welfare and this the wealth that was started and was originated by the people, for the people, will be allocated somewhere else. So I would like much better that maybe people can own their own cars, their autonomous driving cars, and then they can actually let the autonomous driving cars work for them for a couple of hours and kind of generate a little profit from this. And I think we need to think of models that allow people to indeed buy robots and put robots to work for them as individuals or maybe as a cooperative, as an agriculture cooperative when people has autonomous tractors or drones to survey crops and actually they can share the profits of that instead of relying on hiring a large company that is coming to do the robotic service for them. So I'm quite interested on understanding how this can play out. I know it's kind of very kind of blue sky scenario where we still do not understand. We don't have robots yet that can do all the things we plan, but maybe it's a good time to start thinking on how to kind of empower people with robotics. I think that's quite interesting. And as you mentioned, there has been exciting work about this. There is a work of Eduardo Castelo Ferrer that I really like,
I was
inspiring.
going to
So
mention that.
he did a really amazing experiment where he had this painting robot that was basically the researchers set up the full workflow for the robot to auction paints, paint, buy materials, and repeat. And they showed that technologically is possible. So you can do this today. So there are some regulations
And then
you
the
need to go
robot made
around.
the money, which was
Yeah,
raises all sorts of interesting questions, and had to pay the human to bring them the paintbrushes or whatever, like
exactly.
service the
Yeah.
robot. So it was
So
flipped.
yeah, it's super interesting for me. So it shows it's possible. You can have robots generating some profit for you. Now I want to understand this, how this plays out when you have robots at the scale, right? Because it would not be the same just having one single robot. Actually, there could be interactions with people that actually will be participating in these markets. So if I let my car autonomously drive and do Uber for me in the afternoons, what happens with the other person that is doing it by itself? And so how do we foresee these interactions and how do we understand these economic models is super interesting for me.
It is, and it is a natural question to ask if you're a swarm engineer, because it goes towards decentralization, right? And the potential that that allows in terms of scalability and robustness. You can imagine these robots rolling up to a robot repair shop when they need repair. You can imagine them interfacing with another robot if they need to coordinate. So it's a natural thinking process, I think, for a swarm engineer. And I really like that you're talking to people in economics and in the broader landscape to see where it makes sense and sort of how their theories work. So watch the space, I guess. Thanks so much, David, for being here with us on Swarm Slack today.
No, it's exciting. I'm really happy with the work you're doing. I think we were missing, and it's the right moment to start thinking on robots at really large numbers. We have seen just in CES now the recent developments,
Gosh.
lots of excitement about the new technologies, very effective robots. I need to say that my vision is that humanoids will play a role on robotics, but it will not be all humanoids. But I need to agree that what was shown this year is just fantastic. So they are extremely capable robots, and now we should start thinking on how they will interact with each other and how we will interact with the groups of robots. So that's
I mean, it's part of the ecosystem, and we humans are a swarm and how we interact as well. So it is quite a natural development to just include everything in the
indeed.
mix.
Indeed. And thanks for having the Slack for giving actually visibility to the research and inviting.
No, thank you. Thanks. All right. Well, great. Have a great day, David.
Thank you,
Bye.
Sabine. Bye bye.